Domain and range. So I just want to remind you that, let me show you what tonight's homework's going to look like. Tonight's homework is a bunch of blanks there. You can't see what I'm looking at, can you? There we go. Tonight's homework is a bunch of blanks. But what it's going to refer to is, if you look at number 1, that is referring to graph number 1 on last night's homework. So you would look, f of x is the original graph. You're going to tell me the domain and range, which I'm going to show you how to do it now, this period. And then in another notation, interval notation, you'll do the same thing for that graph. Then the translated graph that you moved 3 units to the left, that's what you're going to tell me the domain and range of here and there. Okay, so for the first 12 problems of last night's homework, that's what I'm referring to. So you're going to have this one out while you're doing tonight's homework. So let's talk domain and range. Let's see. Domain, we've talked about before that it is all of the included x values. And range is all of the included y values. Now, up until now, this problem right here may be the only kind of domain and range you've seen. I'm not sure. But this is just a set of 4 points. And if I wanted to list the domain of those 4 points, I would do this squiggly line called a brace. And I would list all of the x values in order from least to greatest. So if I look at just the x values, 0, -2, -5, and 12, what's the smallest x value there? -5, and then next smallest, -2, then 0, then 12. And I would close it off with another brace. Easy enough? Range, what would I do? I would list the y values in order from least to greatest. So what's the smallest y value there? -0.5, because it's the only negative one. And then do you notice that both of these have a 1 as the y value? We only need to list it once. And then a 3. We don't duplicate because we're not trying to show how many times these things happen. We're just trying to show what y values are represented. Okay, we're not concerned with how many times they're represented. All right, but with all of these graphs, we don't necessarily just have a set of points. So what does that mean for us? Well, I'm going to kind of skip this. There's 2 different forms, inequality symbols and this interval notation. You can go back and look at this after I jump to an actual example. Kind of feel like it's a little bit easier to just jump straight in. All right, so domain deals with what letter? X. What direction does my x-axis go? Left to right. So domain is talking about left to right boundaries. So in other words, I want to find the absolute smallest window I possibly can that will still show me every piece of my graph. Which means that from left to right, I could close in all the way to here, couldn't I? Because that's where my graph ends. I could close in all the way to there. Right? What about on this side? I could close in all the way to there. That is the smallest I could make it left to right and still be able to see my entire graph. Yes? So that means it goes from -4 up to 5. Yeah? That's my domain. So -4 is the smallest number. We always write smallest first. So -4 is less than or equal to x is less than or equal to 5. That's how I'd write my domain. Questions about that? Range is the exact same idea, except range deals with y, so it's going to deal with squishing my y-axis. So let's see, from the bottom, I can go all the way up to there. Yeah? And this one, keeping it perfectly horizontal, I can go all the way down to there. So let's see, that's 3 on the top and -3 on the bottom. So how would I write my range? Again, smallest number comes first. So -3 is less than or equal to what? Y is less than or equal to +3. So far, so good? All right. I'm going to kind of skip around a little bit here. Look at this one, see if you can write the domain and the range for it. This is the exact same graph, just moved. And we'll talk about the movement in a minute, but see if you can come up with the domain and the range for that. So domain left to right, it looks like -3 is as far as I can come in on the left. And +6 is where it ends here. Now I do want to make sure to note that even though it ends at +6, that's not an arrow, because if it was an arrow meaning it continued on, that would change things up for me. But I don't have an arrow yet. So what's my domain? -3 is less than or equal to x is less than or equal to 6. Questions about that? All right, range. What have we got? -1 to 5. So I would say -1 is less than or equal to y is less than or equal to 5. Any questions about that so far? Pretty reasonable? Okay, now let's talk about this interval notation now. Interval notation is a kind of a shorthand way of writing all this. Okay, it's a little bit easier. Now, whenever you have the or equals to sign, and most of the time we're going to have less than or equal to, but whenever we have that or equals to sign, we're going to have to use this square bracket here. See the square bracket that comes up in various places? Every time it comes up is when you have that or equals to with your inequality. All right? So, I have an or equals to right here and an or equals to there. In fact, all of these have or equals to. So what that means is I have square brackets, and then I'm going to put the smaller number, comma, the bigger number, and another square bracket. Easy? So what would the range look like? Square bracket, -3, comma, 3, and another square bracket. What would it look like over here? Domain, square bracket, -3, comma what? 6, and then range, again with square brackets, -1 and 5. Okay? Now, let me explain a little bit about where these square brackets come from. Do you remember doing graphs like that on a number line? Where you had the open circle, closed circle, shaded one direction or whatever. Where this bracket or the closed bracket comes in is when you would have a closed circle, that would be represented by a square bracket. If you had an open circle, that would be represented by a parentheses. So the way I would write this in interval notation is I would write -1, has an open circle on it, which is why it has the parentheses, and 0 has a closed circle on it, which is why it has the bracket. Kind of sort of makes sense? So when I'm talking about these, I'm including -3, which is why there's a bracket on -3. Okay? And we're going to be including all of those except for when we get to cases like these guys. Now, before we get to that case, let's talk about how this graph was moved from here, because it's the same graph, right? Is there any kind of reflection going on? No. By the way, which one is f of x, left or right? Left is f of x, right is g of x. Okay, so there's no reflection of any kind. Does it look like there's any stretch or compression? No? How could I tell? Let's think about our domain and range. How wide is this graph? I know where it goes from and where it goes to, but I could also think if it goes from -4 to +5, doesn't that mean it's 9 units wide? Is this one still 9 units wide? So there's no change there. What about this one? How many units tall is it? 6? Is it still 6 units tall? So because the dimensions have not changed, there's no stretching or compression going on of any kind. Okay? So we just have a shift. So I'm going to pick a point. I'll pick this point, for example. And I just need to see how is it moved to get to here. It looks like it's moved in two different directions, right? It's moved how? Up 2. So that would be a k value of 2. And how else? It needs to get to -1, -1. So it needs to get to there. So it moved up 2 and right 1. So I have a -1. Right 1 means I have an h value of +1 that looks like -1 when I put it in the parentheses. Okay? So far so good? That's what we're doing today. Okay? Now, this next one, things change a little bit. How does it change? A little bit hard to see, but we have arrows. Those are arrows. These guys are arrows going that way. What does that do to me? Well, if I were to try and look at my domain, and I try and squeeze in here, like I did on the last one, can I say that this is how wide my graph is? Can I say that that's how wide my graph is? No. Because, unlike the other one, I could see the graph in its entirety on the one that was given to me, right? This one I can't see the whole graph because those arrows mean it keeps going. So in other words, if I could see the whole graph, which it would be impossible to, it would have to keep getting wider and wider and wider, wouldn't it? Because it's going to keep going up and up and out. Yeah? So is there a place where I would stop getting wider? Which means what? It means we have all real numbers, right? We've heard of all real numbers before. So how do I express that in this inequality notation, let alone the interval notation? Well, what that means is, as far as I can think of to the left would be -infinity. And as far as I could think of to the right would be what? +infinity. So I have my inequality. The difference with infinity and -infinity, we cannot use the or equals to part of our inequality. All I can say is -infinity is less than x, which is less than greater than +infinity. Why can't I use the or equals to? Because you can never actually reach infinity. You can count as long as you want to, and it's not like a million where you could actually reach the number. You can't reach infinity or -infinity. So what does that mean about interval notation? Well, I'm going to have -infinity, comma, infinity, but am I going to use parentheses or brackets? Parentheses. Why? Because I don't have the or equals to parts. I can never actually be at -infinity or infinity. And both of those are just alternative ways of writing all real numbers. So? Good answer. All right, let's talk range now. So range, I can squish all the way up to here for my range, right? But where do I put the top? Because those arrows mean I can't just stop it here. It's going to keep going and going and going and going. So what does that mean about the top? Top's going to infinity. Is the bottom going to infinity? No. So let's see. This is the lowest point, so I could say that all of my y values are greater than or equal to that lowest point. What is that lowest point? -2. Everything is greater than or equal to, because it does get there, -2. What's that going to look like on my interval notation? What's the lowest point on my graph? -2, right? Does that -2 get a square bracket or a parentheses? Square bracket because it has the or equals to. What's the highest point? That's the one where it keeps going, right? So infinity, and I can't put a square bracket on infinity. So the way that one looks in interval notation, I have one bracket and one parentheses, and it goes from -2 all the way up to +infinity. Okay. So. See if, we're not going to worry about the equation on this one because it's a little different than what we've done. But see if you can write the domain and the range in both inequality notation and interval notation here. What's my domain? Left to right, is there any stopping it? No? So how do I write that in inequality notation? Negative infinity is less than x is less than infinity. What does that look like in interval notation? Parentheses, negative infinity, comma, infinity. What's another word for that? Or another phrase? All real numbers. Okay. My range. This time, if I look at my two directions, which one has no stopping point? Going down, right? So I don't have a greater than thing. I have a less than, because everything is less than this number right there. So what's my range? Y is what? Less than or equal to 2, right? Because that's where my end is, my boundary. So how do I write that in interval notation? What's smaller? 2, or is it going to be positive infinity or negative infinity this time? Negative infinity. So negative infinity has to come first because it's less than 2. I have a parentheses on negative infinity and a square bracket on 2. Questions there? All right, turn the page. We're almost done because I'm going to stop at this. I'm not going to do that part. So we're just looking at these ones. Okay, so why don't you take a minute, see if you can write the domain and range in both notations for each of these, and then if you're feeling really adventurous, try and write the equation of how this one has been transformed from this one. Okay, so I'll give you a minute to do that. By the way, even though it almost looks like a parabola, there are no arrows on this. So it does indeed stop here, and then again here and here. All right, so what is my domain in this one? Negative 3 is less than or equal to x is less than or equal to 3. What is that in interval notation? Negative 3 comma 3 with both sides having the square brackets. Now, out of curiosity, what is my domain for this one? Is it any different? No. My domain's the exact same. What does that mean if my domain is the exact same? What does that tell me? It tells me that horizontally, nothing's going on. There's no stretch horizontally. There's no compression horizontally. There's no shift horizontally. It's exactly the same. Not only is it 6 units wide, but it starts in the same place and it ends in the same place as the original. So horizontally, we got nothing. Let's talk vertically. What's my range here? -6 is less than or equal to y is less than or equal to what? 0. So in interval notation, that would be square bracket -6, comma 0, and another square bracket. Is that the same over here? Okay, so it's changed. What's my lowest point here? 0. Up to what? 3. So 0 and 3 both with, 3 both with square brackets, right? Now, what do you notice about the range? Well, I notice a couple things. First off, we have a reflection, right? It's from the bottom, it's flipping up to the top, right? So that's a, what kind of a reflection? Vertical or horizontal? That's a vertical reflection, which means that's a negative A value. In addition to the vertical reflection, do I have any vertical shift? I don't think I have a shift, because if I look at these points right here, they don't move, do they? They're the exact same 2 points there. It's a reflection and what? If it's not a shift, compression. Because how tall is it over here? Or in other words, I could look here. It is, I'm sorry, right here. It's 6 units tall. How tall is it here? 3. So is it stretching if it starts at 6 and goes to 3, or is it compressing? It's compressing. How much is it compressing? What's it doing? It's cutting in half, right? Which means my A value is not only negative, it's -1/2. And then since we had no shifts left or right, it's just -1/2 times f of x. Okay? What if it was 6 units tall and then it was 2 units tall? That would be 1/3. What if it was 6 and then it went to 18? That would be a stretch factor of 3. All right? So that's how I would determine that. Any questions there? All right, again, tonight's homework, you need to refer to the graphs on last night's homework to get your answers, all right? Happy studying.